something that I sometimes tell students to help them remember this is if we think of the bottom, if we think of the bottom as the low, the one that's lowest, and then the top, that's low, this is high. So one little thing calculus teachers have been using for a very long time to help students remember is that the quotient rule is low D high minus high D low all over low lower, low squared. D means derivative. So low times the derivative of the high minus high times the derivative of the low all over low low or low squared. There. So Austin and Trevor made me a song about it to help you. Silas is also here. He's doing all of the noises in the background that may, who even knows what they are, but it's pretty good. I don't know if that actually picks it up. I think that's Silas.
I walk into class, open up my book, make sure that I pass. Derivative, that's what we working on. Working on my homework from dusk till dawn. One day in Calc said she got a little sick.
Yeah, Calc is me.
I start to listen because you know I want to hear it. She says the quotient rule is gonna help you out a lot. I said, what's that? She said, boy, let me tell you what. Low be high, high be low, high be low. Where's the bottom? Where's the bottom? How we roll? Low be high, high be low, high be low. It's the quotient rule, man. You already know.
There's 3 verses.
Yeah, there's 3.
I'll let y'all listen to it. It's good. This is Trevor Nance right here.
It's the chef king, yeah, you know we cool. Getting all the babes with that quotient rule. You know, baby. Take the river till the bottom, let them make yeah, boy. Yeah, you know, chef king about to be swimming in that credit, about to be around. Yeah, you know it. Make say, cooking coming soon, baby. Low be high. And that's how we roll. That's how we roll. Low be high. Low be high. That's how we roll. High be high. Man, you already know. Stacks on the beat again. Young stacks on the beat. Here's something. Chef gang on the block. Got that bass open. Quotient rule. We got a little ratchet. Here we go. Stack in the action. Low be high. First man, you know how it goes. Then you flip it around while shorty's down below. Bottom, don't be funny. I want to be talking with the still while I got the lunch. It is cookie, baby. You know we cookie, baby. It's a hot beat. It's a hot beat. Baby hot. Baby hot. Where that bottom? How we roll? Baby hot. How we low? You already know why.
So, this is good, wasn't it? So, I will extend the same extra credit offer to all of you.
I can't beat that.
Now, I am going to limit to just one song, and it can be on any calculus topic that you would want. But it is up to 10 points on a test.
Shoot, I need it.
10 points up to. Now, obviously, this on a test. You can only do it one time. I did one time say that you could do it like unlimited times, and one student was like going to cut a whole album. Oh no! I can't even remember who it was, but somebody made like 3 or 4 songs before I finally said, "That's enough. No more extra credit. I'm cutting it off." But, yeah. It wasn't all in the same quarter, but still, yeah. So I'm only allowing you to do it once, and it doesn't have to be on quotient rule. It could be on anything. Like you could do one about power rule. You could do one on chain rule. You could wait and do one like we're going to learn L'Hopital's rule. Like this is for the whole year. But you can work together, and each of you can get the 10 points if it is high quality, and both of you are contributing more than just noises. Silas was just a freshman whenever he did this. He wasn't in calculus, so he was just doing it for fun. But you must both of you have to have a voice, and it has to be high quality. Obviously, this was very high quality. I'm not saying you got to have like quite this level of creativity because I feel like this is really good. There may be singing voices could use a little work sometimes, it can be anything. Somebody should get Logan in their group. He's really good. He could. It would be so good if he could come up with one like the Grinch, like you're saying. Your Grinch was so good. If there was a calculus version like of the Grinch. I don't want to be the Grinch. Don't make me the Grinch. So that might not get you 10 points. But it can't be. She's a mean one, Mrs. Hyatt. It can be a parody. Like I would, like they came up with their own here, but like parodies are fine. But like you can't just record yourself saying roses are red, violets are blue. I like the quotient rule, don't you? Or something like that's not going to get you 10 points. It has to be about a calculus topic, and like if it's clearly done really quickly without much effort, you won't get the full 10 points. But if there's effort gone into it, I will not grade you like on your quality of singing voice. So like if you're hitting the wrong notes a little, that's okay. But like as far as creativity, quality of the recording, that sort of stuff, you know, your lyrics and whatnot, that I will consider. But so this offer stands up until the end of the year. You can work together, or you could do your own. But if you're willing to embarrass yourself and create, then it could live on, because I've listened ever since they did this. We've listened to it every year since, and probably will until I retire. So.
You got make time. I don't have it into my schedule.
All right, so it is like 10 bathroom passes. I mean, if I would suggest just taking the 10 points, because you might get mugged and somebody might steal your bathroom passes. But if you would rather have the cash. Okay. I will also remind you that if you were planning on it for this quarter, October 22nd is the last day for grades this quarter, so it would have to be turned in by then if you want the points to go on this quarter. Okay. All right, so let's do a problem. Okay. The most difficult part about quotient rule problems is simplifying. So, like actually doing the problem is not so bad, but the simplifying to get it to match what an answer choice is what's more difficult. So, if we're going to take the derivative here, this is my low, this is my high here. So when I take my derivative, I'm going to do a dy dx, or you could call it y prime. Either one is acceptable notation. So it's low, so it's x squared plus 2x. The one on the bottom has to be g of x. So the one on the bottom has to be g of x. With power rule, it doesn't matter. You can pick either one. But with quotient rule, it does. The bottom has to be g of x because you got this minus sign right here, so the order matters. Derivative of the high is just 3 here. Minus high, so 3x minus 4, times the derivative of the low, 2x plus 2. And make sure you're putting everything in parentheses like I am, because you have to multiply those two together. If you're not, you might mess that up. And then low, so low squared, x squared plus 2x squared. I'm going to tell you, you generally do not want to expand the denominator. Leave it like it is. Okay? There might be some rare cases where it might help, but generally we do not want to expand that denominator. We want to just simplify the numerator and then see if there's anything we can do from there. So we got 3x squared plus 6x minus, I'm going to put some parentheses here because that negative has to be distributed. So I'm going to have, here I got to distribute 6x squared plus 6x minus 8x minus 8. This is all over x squared plus 2x squared. And then you can either combine your like terms here or distribute your negative, whichever one you want to do. I'm going to do both at one time, if I can do it without messing it up. So when you put these two right here together, you're going to get negative 2x, but then you're going to distribute that negative. So that's going to be minus 6x squared plus 2x plus 8. And it is very tempting on this because you're really only working with the numerator right here to just like quit writing that denominator. I can live with it on a multiple choice question, but if you do that on a free response question, they're going to count off for that. That's wrong. So you want to write that denominator each time, even if it is a pain. The dy dx, it's okay as long as you got like a string of equal signs, so it's clear that you worked straight down. So like if you don't, so like if I don't write it there, it's okay, just as long as I've got those equal signs, so it shows that this is still equivalent to dy dx. So we get negative 3x squared plus 8x plus 8 over x squared plus 2x squared. I don't think that will factor. So I think that it's fine. But let me just show you this. Let me show you this right here. I'm going to show you two things on the calculator. Because one of your free response questions is this week is calculator active, and you'll need to be able to do this. So first of all, I will show you that if you just want to see if this will factor, if you get your calculator and you hit F2, F2 right here, which is your algebra. Number 2 is factor. And if I'm just typing in the numerator here to see if it'll factor, negative 3x to the second plus 8x plus 8. I can't. I'm sorry. I wish that I could, but I could. I mean, I can make it a little bigger, but I can't. Actually, I can't even make it bigger at all. All right, so they factor out negative, but that doesn't do anything, right? So nothing will factor and cancel here, so you would just leave your answer like this. This is our derivative, so this would be our answer. All right, now let me show you.
So it doesn't factor at all.
Right, it doesn't factor at all.
You need to factor out an x squared plus 2x.
You could here, you could here, if for some reason you needed to, you could factor an x out of that x squared plus 2x, but it would look like this. It would still be squared on the outside.
Yeah, we ain't doing that.
Which you could write like this.
I was thinking you could just take,
Like take an x out.
from the top and the bottom.
No, you definitely cannot do that.
Okay.
Definitely don't do that. Because you got plus signs and plus and minus signs in between everything. You cannot do
You
it.
can't do that when there's plus signs.
No. Only,
Not knowing that has screwed me over.
it has a bunch of times. Yeah. So if you have x squared plus 3x minus 4. So like when you can factor it, you probably wouldn't. But it's these times where you can't factor that. Like you if I gave you that, you'd probably try to factor that top part.
I would absolutely take out x. Yeah, I would cancel everything in there. And I would get that's exactly what I would get.
Thomas, you remember what I was saying? This is if this is the old days and teachers could still smack kids in the hand with a ruler, you would have to get smacked in the ruler for that if this was 50 years ago. Or 100, however long ago they were smacking kids with rulers. Yeah, so.
I would just stop doing the calculation.
Good thing we have a strong no corporal punishment policy now
That's right.
that I'm going to abide by. Because if this was 100 years ago, and I just didn't even know any better, all teachers just smacked kids with the rulers. I would be smacking Thomas's hand with the ruler every time I saw this. Corporal. Capital would really be severe. Yeah. For canceling the x squared when there's plus signs. Now that would be severe. I bet you wouldn't cancel incorrectly as much. But like Thomas said, probably most kids would just quit and stay home. Yeah, and you probably should, because that can happen on accident. But you might see it like this, but that is all. All right, let me show you guys this on the calculator. This calculator, I have not shown you thus far, because so far we have been dealing with super simple derivatives, or most part, but this calculator will take derivatives. I'm not encouraging you to use this except for to check your work right now, because most of this is going to show up on a calculator inactive section, but there is one problem on your FRQ, that first FRQ that you have. I don't know if I put it on there, but on that first FRQ that you have for this week, it is calculator active. I can't remember if I wrote it on there or not, but it was. But the first one, I did. There was one extra one up there where somebody did not get one. So that might be you, Selena. But on that problem, that first problem, you are going to need to use the calculator to take a derivative, because it's going to have one that you don't know how to take the derivative of yet. So if you click F3 on this, it gives you all of your calculus options, and the very first one is differentiate. So it's F3. So click F3, and this little D will come up here. Yep, differentiate. And then you're going to type in your equation. Make sure you put parentheses around the top and then parentheses separate around the bottom. So 3x minus 4 over x squared plus 2x. And then just like with the solve feature, you have to tell it what variable you're taking the derivative of, which is an x. So you got to put comma x and then close your parentheses. And so it will take the derivative for you whenever you do that. You can see they simplified it like I did right there, where they got the x squared and the x plus 2 squared, but it's equivalent. You type in d, which is x3, and differentiate, and then you type in the equation, and you have to put comma x and then close your parentheses.
Above 9.
If yours says too few arguments, you probably have closed your parentheses too early. Forgot to put comma x. Yeah. Take the parentheses from the end after the x. Yeah, take, well, actually, you need one there too. Over here at the end of the note. Yeah. No, not one right there. Not around it. Just, you have to make sure every parentheses that's open is closed. Oh, you need a parentheses in front of your 3x. You need another. Yeah. Because see, what if you don't have it there, it's closing the derivative parentheses right here, so it's making all that stuff. It should work now. Everybody get theirs to work? See? It's your parentheses, I bet, for sure. You need another parenthesis. All right, don't put two parentheses right there. Get rid of one of those. So just that last parenthesis behind that x. Yeah. Because whenever it does differentiate, it opens a parenthesis. That one doesn't need to be closed till after you put your comma x. All right. Those of you that are taking coding classes, the parentheses and brackets and stuff matter a lot. Probably. I'm not sure what language you're... Yeah. It's similar whenever you're using this. They have to be closed, and they have to be in the right order. Or you're not... Daniel said not to ask you about the coding class.
Please don't. I'm done with that. Today was last day of class. I'm not going to.
Okay.
Okay. Sure.
All right.
I passed the class. All the time.
All right.
I passed the class.
Okay. So if we look at this problem right here, and I guess this was a continuation of other notes. The reason it's 4 and 5 instead of... Oh, I know. It's examples 4 and 5 from the textbook, I think, is the reason I numbered it like that. From where they're examples, not their problem numbers. So if I have this problem, it's got to use the quotient rule, but I really don't like having that complex fraction right there. So you got a couple options of how to deal with it. You can multiply top and bottom by x. It will get rid of it. Or you could just do an x to the negative 1. Like we could either make this 3 minus x to the negative 1 over x plus 5. Or we could...
what Jack said.
What?
The calculator.
Or plug it in the calculator, but I'm telling you, most of it's not going to be calculator active, so. Or we could multiply the top by x and the bottom by x. That'll give us where we don't have negative exponents to deal with, so let's do that. Now this is not taking the derivative, so right here, I need to put, this is still f of x. This is not f prime, this is f of x. Equals, and then so we'll distribute this x right here, so we'll get 3x minus 1, because when I multiply x times 1 over x, it's just going to give me 1. Over, I could distribute here or leave it like this. It really doesn't matter, but it'll probably be a little easier if I distribute. So x squared plus 5x. This way we don't have to deal with negative exponents. So if we take our derivative now, we are going to do low d high minus high d low all over low low. So low is x squared plus 5x times the derivative of the high, which is 3, minus high, which is 3x minus 1, derivative of the low, 2x plus 5, all over low low, so x squared plus 5x squared.
I'm tripping hard right now. Hold on. Oh, I'm looking at the wrong problem. Okay.
Okay. Yes, it's 2x plus 5. Alright, does everybody know where everything came from and okay with where everything is at? Okay. Alright, so at this point you found the derivative. Like if this was free response and it was only asking for the derivative, you could stop. But usually it's almost always asking you to plug something else in. You need to simplify it to make that easier. You pretty much are always going to have to simplify this, but or it's going to be multiple choice where you got to simplify it. But technically we have found the derivative here. The calculus is done. But we're probably not going to be able to leave it like this, so you got to simplify. So we'll get 3x squared plus 15x. Yeah, it's where bad things happen. All this algebra. So we got 6x squared. I'm going to do plus 15 minus 2 is going to give me plus 13x. I'm going to go ahead and combine those. Minus 5 all over x squared plus 5x squared.
It's freaking nasty, man.
Are you recording?
I have some extra masks up there if yours is no longer sanitary.
I don't see the red button.
I hit. Let's make.
I watched you guys pull.
Sometimes it does this. All right, it's either though. It makes me nervous that it's quit on me.
There we go.
Okay, it was recording, but.
I remember watching you smack that thing.
All right, so we distribute that negative. So 3x squared plus 15x minus 6x squared minus 13x plus 5 all over x squared plus 5x squared negative 3x squared plus 2x plus 5. I got that right? Okay. X squared plus 5x squared. And will that factor? Somebody already checked. Will that factor? Check it. Just double check with that.
I don't have that.
Oh.
Stick that junk in the calculator.
Wrong, Joe.
What have you got, Jack?
You don't even know. It's a freaking number.
Wait, how is 15x positive? Yeah, for real.
How is it not
Oh, yeah, right. Wait.
15 is positive. Oh, you mean here?
What?
What's
Wait,
Here,
wait,
this
wait,
15x
three
is
times
just.
five. Wait, that's
What's 3 times
I
8?
found out why I messed up. At the beginning, I inscribed it as x squared minus 5x.
Oh yeah, there we go.
Wait.
That would be it.
I thought 5 times 3 was 5. What?
There's another issue.
3 times 8.
Where?
On the very first line, that's kind of bad. And you're distributing. Would that be 3x times 8x? The second part. Like over 3x times 8x.
You're gonna get 15 and negative 2.
That's right. How's it going?
You're talking about this here?
No, I'm saying like, if you did 3x times 8x, right?
Where are you seeing the 8x?
Is that an 8x? I can't tell.
This right here, that's a 2.
That's a 2? Oh, I see. Okay, that's what.
Okay. All right, questions? Okay, now let me tell you that you do not have to use the quotient rule for every division problem. This is not a calculator problem. So, you could use quotient rule on this. But because you've only got one thing in the denominator here, what else could we use to change the way this looks? Not Bobo-Bot. No, that's just limits as x approaches infinity. If they asked us for horizontal asymptote, we would.
Bring the x squared to the top.
You can do it that way. I usually think of it this way. Love connection. Like this. And so, you can write this as x to the third over x squared minus 4x over x squared, which if you simplify the I used a minus there. Yeah. You'll just get x minus and then 4 over x, but you could write that as x minus 4x to the negative 1. So f of x equals, well, we haven't taken the derivative yet. So x to the negative 1 is going to be better because it's going to make it easier for us to take the derivative. So right now, we have not taken the derivative yet. This is still f of x. So like I've got a string of equal signs here. I'm writing f of x equals x minus 4x to the negative 1. Now I can just use the power rule, right? So for f prime of x, I just get 1 plus 4x to the negative 2. You can leave it like this. They might move it back down. They might even get common denominators.
Yeah,
Because they like to do that. X squared plus 4 x squared. So any of those are acceptable. Yeah, it's all still the same. So any of those are acceptable, but our textbook's probably going to have that as the answer. And a multiple choice test or quiz, multiple choice question might have that as the answer.
If you were to give us a question, which one would it be?
On Delta Math, it would probably be like this. It's going to depend on whether or not it ends up on the multiple choice or the free response. So in free response, it would be fine to leave this right here. This is free response. But if it's multiple choice, I pull straight from AP questions, and it's probably going to look like that. Even though it can go either way, because AP multiple choice questions are kind of crazy, the way they leave answers. Like, they might have some of the answer choices with negative exponents and some of them not. They won't have any that are equivalent. They wouldn't put both of these answers.
you know what? They might have some that are like halfway simplified.
Yeah, like what they do is they would, yeah, they might have like A is 1 plus 4x squared, something like that. They might say B is 1 minus 4x to the negative 1. C might be the actual answer, x squared plus 4 over x squared. And then D might be something like 4 over x squared minus 1 or something like that.
I don't like how they're all the same.
Yeah. But the only one that is correct is this one right here.
Well, there's no way of knowing that. It's really confusing.
There is a way of knowing that. But yeah. Yeah, AP probably would even have like maybe an E where they got another 4 minus x squared over x squared or something, and then your pick the longest answer wouldn't even work. So that's what they'll look like for Okay. All right, here we go. All right. So
this could just be 1 over 1, if you ask me.
I mean, that's squared.
Oh, it's squared?
Thomas can't. What are you can't? Yeah, that's squared. If it was squared, that would be exactly what you would do. But it's got to be squared. Thomas, my favorite back there. Thomas cancels like this. It's back there, but it's a fun joke because Thomas cancels like this. He would cancel this n right here with the n in sign, which would be 1 times SIX, which is 1 times 6, which is 6. 6 is the answer.
Did you actually do that?
No, I found that was just like a joke I saw, like somewhere online or something. Huh?
I did something similar to that last week.
Yeah.
I was doing on the test, I was like, oh, I'm so smart.
Yeah.
I made it work.
Yeah.
I took a 0 out of cosine and made it 0.
Yeah.
This is just multiplied
Yeah.
by 0.
So
It do not matter.
you cannot cancel anything right here. So you got to use quotient rule for this one. So you got sine of x times the derivative of 1 minus cosine x. So what's the derivative of 1? 0. It's going to go away. Derivative of cosine is negative sine, but you already got the minus in front of this, so it's going to become sine
So it's just sine
x minus pi, which is 1 minus cosine x, times the derivative of sine, which is cosine, all over sine squared.
Yeah, I was gonna say,
You have to distribute the cosine to both of these. Yeah. So sine x times sine x is sine squared x. Sine x plus sine x is sine. The 2 sine x. Minus, we're going to have cosine
Wait,
x.
why is it sine squared x instead of sine x squared?
So it's just weird notation that they use for trig functions. So it means sine x squared. So whenever we put the square right here, it's the same. But if you just write it without the parentheses like this, then that is sine of x squared. Like that. So the square, like if we write it squared, that square has to go right there. Or you can write it this way. It's okay to write it
I'll
this
do
way
it that way.
if you like that better.
The other one's confusing.
But just make sure you got the parentheses around them if you write it that way. So, over sine squared x. So, let's distribute first. So we get sine squared x minus cosine x plus cosine squared x over sine squared x. We could do a love connection, but there's something else I'd rather do first.
Change the sign to
Those things. And then you get
Sine squared x plus cosine squared x equals 1. So I will get 1 minus cosine x over sine squared x. I think they will probably leave it like this. There is a chance that they do love connection. Yeah, it's squared on the bottom, it's not squared on the top. There's a chance they do love connection. If they do, it's
Isn't that pretty much what we started with?
almost, you got a sign squared in the bottom. Instead of,
Just squared the bottom.
yeah, but that rule would not always work with all problems. So
So if that were to be a 1 minus cosine squared x, it would just be 1.
yes, yeah, if that cosine was squared there, it would just be 1.
You know good stuff.
Okay. All right, questions?
I feel the rule, but it's the simplified part of that. So.
Yeah, the simplifying is the hardest part of this. The rule, usually students do fairly well with, but it's the simplifying that gets you. All right, so homework. You have 7 through 12 and 27 through 40. Watch out right here. Some of these do not require the quotient rule. So some of them are like that third or fourth problem that we did where we did the love connection. So there's several of those there.
You just knock out odds, right?
Oh.
Look, here I am.
Let's see. Oh, wait. Go to 36 instead of 40. Should do it every time. I should do it every time, like, yeah. Like, you never pay full price for anything at Belk. Belk is always, like, everything in the store is on sale for some amount.
Mark it up.
Just mark it up and cut it down. I should do that with all. Somehow it still feels a little better if it says it's 25% off, doesn't it? Like,
I mean, it just does.
even if it, so you know, I should start doing that. It just feels, it makes me seem a little nicer, even if I, yeah.
Make it seem like there's a lot, and then just take off 2 problems.
No, what the frick is wrong with you? No, you ain't abiding to the graph anymore.
Let's just do 29 together.
Frick. You shoved a pencil in my ear.
Because we didn't do one like this.
That is frick.
You want to do 30 since 29's in the back of the book? Okay, 30's fine. Sorry if you already started writing down that.
Yeah, it's not as far.
Okay, so if you do this problem as it is right now, you would have to use the product rule and the quotient rule, right? If we did it as it is right now, because you would have to use the product rule because these things are multiplied, but then you have this quotient rule inside of that. We would probably like to avoid having to do that, right? So we will distribute here first. So you'll get x to the 4th minus, what's that going to be when I distribute to that second one? 2x to the 4th over x plus 1. And we get that because we're doing x to the 4th times the 2 over x plus 1. So the x to the 4th is in a numerator, right? Okay? And so when we do this, to take the derivative, x to the 4th, we just use the power rule. It's just 4x cubed. And then we're going to have to use the quotient rule on that second part. So here is where we'll do x plus 1 times 8x cubed minus